All right, we're looking at lesson 2.1, relations and functions. So you've talked about these in the past. We're just going to review some definitions here. We'll come back to this exercise. So domain of a relation is a set consisting of all first elements of the ordered pairs. So in that above example, the domain would be the first elements of every ordered pair. So we have 4 ordered pairs. The first element would be the 3, the 7, the 1, and the 4. So when we list them, so domain is, you open up the squiggly brackets for a set, and it'll be, you list them in ascending order. So 1, 3, 4, and 7. If any of them repeated, you would not write it again. Okay, so for a relation, the range is the set of all second elements of the ordered pairs. So again, in this above example, the second element in each ordered pair would be the 2, the 5, the 0, and the 5. So we'll say the range is 0, 2, and 5. We don't need to list 5 twice. We're just listing the elements that would be in the range. I don't need to list them if they are repetitive. All right, so we're going to look at a couple graphs and come up with the domain and range. So we saw in that example that the domain is just a list of numbers if they're individual. All right, looking at these graphs, the domain would be all of the first elements of your ordered pairs. So there's an infinite number of ordered pairs here that are graphed. They're just really small dots all connected. But we're going to look at all of the inputs. So x values, the smallest x value would be all the way out here at -1, not including it because of that open circle there. And then we have x values all along here, okay, that go from -1 all the way. All of this has x values from -1 all the way out to the furthest one. The greatest one here is 3, and it includes 3 because of that closed circle. So we can't list them all out because there's an infinite number of domain values between -1 and 3. So this time we're going to write it as an inequality. So we can say the domain is from -1 less than x. We're not going to include the -1 because of that open circle, all the way up to 3. And you could also write this in interval notation. You could do a parenthesis on -1 and then a square bracket on 3. All right, and now the range for this same graph. So now we're looking at the outputs, okay, the second element in all of the ordered pairs. So outputs are y values. So the lowest y value is -1. Again, open circle there. So we're going to say from -1 less than y. Make sure you change that variable. All the way up to all these y values, all the way up to this highest one is at 3 again. So it's equal to 3. Okay, and again, you could list it as -1 to 3, but parenthesis and square. But that should be a square bracket. All right, we're going to look at this next example. So here we just have a line segment. The domain, so inputs are your x values. It goes from an x value of -2 all the way to an x value of +2, but it does not include the +2. So I'm going to do interval notation here, -2 to +2. And then your range are your outputs or your y values. So it goes from -2 all the way up to 1, but not including the 1. All right, so you can use interval notation or set notation when you write your domain and range. Now the next definition is a function. So functions you did talk about in Algebra 1. A function is a relation. So a relation is just a set of ordered pairs where each element of the domain corresponds to one and only one. That's a huge part here, element in the range. So every element in the domain corresponds to one and only one element in the range. Okay, so not saying 2. No x value may map to 2 different y values. Okay, because you can't have an element in the domain going to more than one element in the range. Okay, so when you look at your domain, in this one it says the domain is 0, 1, and 2. So the domain is the first circle, and you can see the arrows are mapping them. This is your range. All right, we're stating whether or not it is a function. So does every element in the domain correspond to one and only one element in the range? And yes, 0 goes to even, 1 goes to odd, 2 goes to even. So this would be a function. If it's not a function, well, it is. We can move on. All right, so again, domain is 0, 1, and 2. Range is the 2, 4, and 6. So is this a function? Does every element in the domain map to one element in the range? And the problem here is the 1. So not a function. Okay, you can't have the 1 mapping to two different range values, the 4 and the 6. And it says explain why. So no, the domain element 1 corresponds to two range elements. Okay, so we cannot have an element in the domain corresponding to more than one element in the range. All right, here we got a graph. This is a relationship where y is a function of x. All right, draw a vertical line whose equation is x equals 3. So x equals 3, 1, 2, 3, would be a vertical line here at x equals 3 on both graphs. So let me draw that down here as well. Give all output values for each graph at an input of 3. So where does it intersect on this graph? It intersects at these 2 points. So give all output values. So when the input is 3, we have an output of 1, 2, 3, 4, and 1, 2, 3, negative 4. So we'll say negative 4 and 4. And then for B, the output when x is 3 would be at negative 2. Explain which of these relationships is a function and why. So it would have to be B is a function, right? Because no domain, that should be do, element corresponds to more than one range. And if you remember from Algebra 1, this is called the vertical line test. Now, one vertical line alone is not enough to test if it's a function. All right, but the vertical line test is if you drew in vertical lines, if any vertical line intersects your graph more than once, it is not a function. All right, then just a little practice here. State the domain and range of the relation and tell whether or not it's a function. So for this first one, domain are all your inputs. So that would be the 3, 2, 1. So 1, 2, 3, we'll list it. Your range would be the outputs. 1, 3, 2, 2. So again, 1, 2, 3. Is it a function? It is not a function because we have the same domain value of 3, but mapping to two different range values. So not a function. One domain value corresponds to more than one range value. All right, if we look at B here, the domain are all your inputs. So now this one, we're not going to list them because it's a graph that's the points are all connected. All right, so we've got, it goes from an x value of negative 4, and there's no open circle there, all the way out continuous to an x value of 3. So the domain would be negative 4 to 3. The range goes from the lowest value being negative 4, the highest value, I don't know, I want to say that is roughly like 2.5. Oh, no, actually, sorry. The highest one's here. So 3. So -4 to 3. All right. Is it a function? Well, if we drew in lots of vertical lines, no line will touch that graph more than one spot. So it is a function. Every element of the domain corresponds to only one element in the domain of the range. Okay, you want to get used to that definition because that's what you're going to use as a reason talking about relations being functions or not. All right, for C, the domain, I'm going to list it up here. The domain, x values go from -3 to 3, and it is continuous, and they are included, so -3 to 3 in square brackets. The range, lowest value, greatest value, still -3 to 3, including them. Is it a function? No. Right? It fails a vertical line test. Not every element of the domain corresponds to only, so not every element of the domain corresponds to only one element in the range. All right, so bring questions back tomorrow and we can go over them.